Hello and welcome to this last and for fifth monitoring and maintenance lecture in this course, Mastering Artificial Intelligence. So in this lecture, we will give you an example of how to monitor and monitor the deployed models to ensure that they continue to perform well over a period of time and update and retrain them as needed. So let's take a look at the example. And this example is of a familiar example of sentiment analysis. And there the model is being deployed now uh, for, for is used in social media monitoring application. The model predicts the sentiment, positive, negative, or neutral, of user comments or posts in a real-time basis. So how can you go about monitoring this model? How did they go about monitoring? How did the team that deployed this model, how did they do? Let's take a look at that. So first they defined the key performance metrics, right? And the key performance metrics they defined were four: accuracy, precision, recall, and F1 score. And they defined for each sentiment class. Each sentiment class meaning neutral, positive, negative. And they established then thresholds and benchmarks based on the historical performance. So they had something that if they can evaluate their model performance after deployment. Then what they did was they start continuously monitored the model predictions and performance metrics in real time. And in that they logged prediction results, specifically text input, predicted sentiment, and the timestamp. So that's how they started doing the real-time monitoring. Then they compared the incoming data with distribution with the historical data, use statistical tests like case test to detect changes in data distribution, and visualized histograms and density plots of input features to identify any drifts happening after the deployment for a few months, let's put it this way, or even few weeks as such. Then also they track the model performance matrices like accuracy, precision, recall over a period of time. And in that they use the concept drift detection technique to detect changes in the model behavior and implemented ensemble modeling. They created an ensemble of models to compare model predictions with ensemble members. So they had multiple members and they compared their model prediction with the ensemble members. Then monitored prediction errors or residuals for anomalies, and then they used the outlier detection technique, and that helped them identify unusual patterns in the model prediction. They had already defined threshold for performance metrics and drift detection metrics, and that they used to trigger the alerts or notification when the metrics exceeded predefined threshold levels. So they set up this whole mechanism of thresholds and alerts. Then they started collecting user feedback on model predictions and use this feedback to validate predictions as well as to identify misclassifications or error in the predictions. They went on with that. So they went on with that to dynamically adjust monitoring parameters by using these adaptive monitoring strategies based on the contextual factors and implementive adaptive thresholds or sensitivity levels for drift detection. They scheduled periodic model retraining based on the data availability of drift detection signals and automatically triggered model updates when parameters performance metrics degraded beyond the threshold. So they had that automatic model update and retraining setup form. Integrated the monitoring components into model deployment pipeline, automated monitoring tasks and alerting mechanisms that enhance productivity, and finally documented monitoring procedures, thresholds, action taken in response to drift detection, and generated periodic reports summarizing model performance and drift detection results. So, by monitoring the deployed sentiment analysis model using these techniques that we took you through, they could ensure that it continued to perform well over time and adapt to changing conditions or requirements in real time. This proactive approach enabled timely updates and retraining to maintain the model's accuracy and reliability in the real life production environment. So what do we do next? So having looked at how to deploy your model, we will now look at a key element of working with as mastering in artificial intelligence is the collaboration in which you as AI engineer would work with data scientists, domain experts and software engineers to develop comprehensive AI solutions and address real world problems. So how do you handle this softer part of life of collaboration is the topic of next section. So thank you so much for watching this fifth and last monitoring and maintenance lecture in this course, Master in Artificial Intelligence. I hope you are continuing to learn new things, continue to enjoy. And I do look forward to see you again in the next section and lecture. Please feel free to message me if you have any questions. I'll be happy to answer your question and also download the PDF file to take a look at anything that we showed you here.